by substitution, and that is what we're going to go through today. Oftentimes they're going to tell you what you're using to substitute. So to do integration by substitution, let's say using the substitution u equals sine 2x, or otherwise evaluate the integral of 0 to pi by 4 of sine 2x cos 2x. I like to call my integrations I. You don't have to, I like to. No problem. Since they say call u sine 2x, what you're going to do is you're going to differentiate u. So what you're going to do is differentiate u to say du, and we're differentiating u with respect to x. So it's du dx is equal to, when you differentiate sine, you get cos. You're going to get 2 times the cos of 2x. That's how we differentiate. But we can cross multiply the dx to get that du is equal to 2 cos 2x, 2 cos 2x dx. Now look at this. Because u is sine 2x, you're going to have to change the upper and the lower limits of this integral. You have to. So the lower limit is going to be equal to, since this is u, you have to plug in when x is 0. The lower limit is when x is 0. So plugging in when x is 0, what you'll get is sine of 0, because when you plug in 0, that's going to get 0. Sine of 0 is 0, so the lower limit remains 0. Then you need to plug in when x is the upper limit, and the upper limit is pi by 4. So when you plug in x is pi by 4, that will give you the upper limit, and the upper limit will be, plug in pi by 4 in this. Remember, u is sine 2x. So the upper limit will give you now, plugging in pi by 4 here, 2 times pi by 4 will give me the sine of pi by 2. So it's a sine of 2 times pi by 4, and 2 times pi by 4 is pi by 2, and the sine of pi by 2 is 1. So that becomes the upper limit. So now I can rewrite that I is equal to, now remember, u is sine 2x, and du is 2 cos 2x dx. Now, if this is du, this is du is 2 cos 2x dx, then look what I'm saying. If we're to divide both sides by 2, I'm going to write it up here. Just follow it up here, follow up here. If I divide this by 2, what I'm going to get is du over 2, I'm getting du over 2 is equal to cos 2x. du over 2 is cos 2x dx. That would be du over 2. Yeah, man, that would be du over 2 cos 2x dx. So therefore, what am I saying? I can rewrite that I is equal to the integral from, instead of saying 0 to pi by 4, I'm going to write from 0 to 1 of this sine 2x is going to become u. Sine 2x is now u, and then the cos 2x dx is du over 2. This is then du over 2. So now we end up integrating u over 2. So integrating u over 2, we know how to integrate regularly. We add 1 to the power, then we divide by the power of 2. 2 times 2 is 4. And we're going from 0 to 1. Going from 0 to 1. So now we just put in 1 and put in 0. So we end up get that the integral works out to be 1 over 4 minus 0, which is 1 over 4. That's what the integral works out to be. Nice and easy, soft. And you know me already, I love to verify solutions. That is exactly what we should. Integral from 0 to, that was pi by 4, I believe, pi over 4 pi over 4 of sine 2x cos 2x dx. You're going to get the quarter. So this is just a verified solution. It's always good when we get a verification of the solution. And there it is, we get quarter. That's it, we get our quarter. And how we did it by substitution. So this is a popular type of question on Cape Mathematics. Don't tell you which one to use as your substitution, but it says, using an appropriate substitution, evaluate the integral of x times the square root of x squared plus 4. So first thing is, when you get something like this, is usually the one under the square root sign you're going to substitute as u. All right. How do I know? How do I know which one to substitute as u? That's the popular question. Sir, what do I know to substitute as u? You want to substitute something as u that you can differentiate and see the derivative in the question. You want to substitute something for u that you can differentiate and see the derivative of what you substitute for u in the question. Let me show you. For example, if I let u equal x, if u equal x, the derivative is 1. I can't see how that can help me with the question. But if I call u x squared plus 4, look at this. If u is x squared plus 4, then I know that du is going to be 2x dx. Because du over dx would be 2, du over dx is 2x. So I cross multiply the dx to say du is 2x dx. Now this is beneficial. Why is that beneficial? Because if I divide both sides by 2, then what I am getting is, this will tell me that x dx is equal to du over 2. And again, you might say, sir, why is that beneficial? This is super beneficial because this question, I like to call my integrals I. If this is I, then what I know is that I is equal to this integral right here. I can rewrite this as the integral of, this is a product of two things. So I can break this up as the square root of x squared plus 4. Can break this up as the square root of x squared plus 4 times x dx. Remember, this is product. All I did was put the x beside the dx. Yeah, man, but x dx is what? du over 2. So that's how this will now work out to be the integral of x squared plus 4 is u. So we're integrating the square root of u times x dx is now du over 2. This is now du over 2. But then the square root of 2, enough people like to rewrite that now. The square root of u can be written as u to the half. So we have u to the half over 2 du. So now we're good. We're just doing normal integration now. So I is going to work out to be equal to, doing normal integration, we add 1 to the power, so we get u to the 3 over 2, divide by 2 times 3 over 2, 2 times 3 over 2, plus some constant c. So that's going to work out to be u to the 3 over 2, that is u cube square rooted over, now 2 times 3 over 2 is just this 2 cancel this 2, leave 3 plus c. But then again, what was u? U was, so finally the integration is working out to be, or the integral is working out to be u cube, u is x squared plus 4. So it's going to be x squared plus 4, and this is being all cubed. So this is x squared plus 4 all cubed, and then we square root it, and then we divide it by 3 plus some constant c. That's what this works out to be, the square root of x squared plus 4 all cubed over 3 plus some constant c. Of course, you know my style already. I love verifying solution. I love to x squared plus 4 dx. Love to verify solution. There you go. Nice. So we get x squared plus 4 raised to the 3 over 2 times 1 over 3 plus c. This is the same thing as what we have. See, there's the same thing. All we did was, instead of writing it as to the 3 over 2 power, instead of writing it as u to the 3 over 2, we just put it in the square root form. All right, and look at the substitution they used as well. They applied the substitution u equal x squared plus 4. They applied the substitution u equal x squared plus 4. So it's pretty much easy to use this one. All right, so that is that. Nice and easy, soft.